All right, so the workshop that we're all engaged in today is the JavaScript security testing in GitHub Actions. And this counts, the stuff that we're going to talk about works for any kind of application, but we've got a JavaScript Node Express application that we'll be testing specifically. It's the simplest application in the world, and it's not very secure, as you'll find. About me, my name is Zachary Conger. I'm a DevOps engineer here at Stackhawk. I do a lot of, I do a little bit of software development, a lot of automation, a lot of testing and observability stuff. And lately I've been doing a lot of these workshops too, along with Nick. In my spare time, I like to play music. I'm mostly a drummer, ride bikes, take photographs. That's me. But anyway, as we go along, please do ask questions. We've got live help in the chat, and the real action is over in the Discord channel. We'll keep an eye on the Zoom chat too, but you should totally join us over at the Discord channel. We've got a little bit more options in terms of pasting in examples and taking polls and stuff over there. Okay, prerequisites again, one last time. Go grab the guidebook for this so you can get all the configuration examples. Join us in Discord, get a GitHub account. Let us begin. All right, here we go. There's 3 types of security testing that we're going to be working on today. And some people are asking if this is recorded. Yeah, this is recorded. And if you get the guidebook, you've got access to all these materials. You'll have the recording, this slide deck, and of course the guidebook. So we're going to talk about 3 types of security testing today, and we're going to operate with those types of security tests. We're going to automate all of them too in GitHub Actions. So the first, so these are 3 major classes of security testing that are pretty common these days. The first is software composition analysis. And this one has gotten pretty common, pretty ubiquitous. A lot of times it happens behind the scenes without you even knowing about it. But what this is it operates on static code. And it's a type of testing that basically looks at your dependencies catalog. So it'll look at your package.json and your package lock.json files. And it will try and operate through that and find any downstream dependencies, analyze the whole deal, and then come back to you and report on known vulnerabilities in any of the specific library versions that you are pulling into your code whenever you build it. It's very accurate and fast kind of scanning because it's pretty simple. And it's always referring to a database of known vulnerabilities. So it really has no false positives. Anything that it finds, you should fix if you can. Now, I say it sort of has no false positives. And the reason for that is that you might pull in a gigantic library and your application only expresses a small part of that application library. And so you may not actually have the vulnerability evident in your code. And that's where something down the line, a Dast scan, is helpful, is that it will not report on bugs that you haven't expressed. But anyway, that's SCA. And some good examples of SCA, or software composition analysis, are Dependabot, Sneak, and Fossa. Dependabot is the one that we're going to be working with today, and that's built into GitHub. Sneak is a really popular tool, very excellent tool for finding vulnerabilities in your dependencies. And Fossa is an open source project that does the same thing. I haven't actually worked with that very much, but Dependabot and Sneak, definitely awesome tools. Next type of security testing we'll look at is SAST, or static application security testing. This is another type of scanning that operates on static code, but it goes a little bit more in depth. So what it does is it will take your code and it'll try and build it and index it all into a type of database that it can search for patterns that indicate that you have some vulnerabilities, some security vulnerabilities in your code. It's super cool because when it reports, it's able to report on the vulnerabilities that it finds by file and by line. So that's really helpful for developers. It really pulls them into exactly where the problem is and what it is. Usually has great descriptions. This, unlike SCA, is finding your bugs, not bugs in the dependencies that you pull in. Unfortunately, it's slower than SCA, probably for obvious reasons. It's doing a lot more in-depth analysis. And it can be subject to high false positives. So you just have to be aware of that it may find patterns that it thinks are vulnerabilities, but it's just not, at least the state of the art right now is not advanced enough that it's able to weed out the false positives. So you just have to be aware of that when you use a tool like this. Some great examples of SAST are CodeQL, SonarQube, and checkmarks. And CodeQL is the one that we're going to be using today. That's built into GitHub. And CodeQL is really an excellent tool for automation of SAST scans. And then finally, we'll look at Dast Scanning. So Dast is Dynamic Application Security Testing. And this, unlike the other types of scans, operates on your code. So it actually, what you need to do to run this is you fire up your application, then you fire up the Dast scanner. The Dast scanner probes the application. It's looking for an HTTP or HTTPS open port, and it's going to spider it and look for any routes that it can test. And for every route that it finds, it will send in test requests and analyze the test responses from the application. And from those probes and responses, it tries to determine if there are vulnerabilities. So it's great because it reports on suspected vulnerabilities with input and output details. So you can take those inputs and outputs and you can actually take those yourself and replay them against the application and convince yourself that what it found is actually a true problem. So it usually has really good concrete examples. It finds your bugs and it doesn't suffer from high false positives. There are sometimes some false positives, but the rate is much lower than with SAST. And when it finds issues, those issues really are expressed in your application, like for sure. In SAST, they might be theoretically exploitable, but in Dast, you know that you've got a problem if it finds a real issue and you determine that it's for real. So Dast scanning can be a little bit slow, and that really varies based on how you scan. There's usually a lot of tunability to Dast tools to speed up the scans, or you can sort of limit the scope of what you're scanning. Like if it's an open API spec that you're scanning, for instance, you can say, hey, I want to focus on these routes. You can split it up and run different scans. Anyway, there's ways to speed it up, but those are the characteristics of Dast. The types of tools that are available for this are Stackhawk, which is our application. There's OWASP Zap, which is the most popular open source application out there for Dast scanning. And Stackhawk is actually based on OWASP Zap. We've taken it and added some stuff to it and tried to make it a lot easier to automate. And then finally, Burp Suite is one that a lot of people probably have heard of. It's kind of one of the old players in the space, and it's a very popular tool for penetration testers. We're not looking at that one today, but we think, obviously we're biased, but we think Stackhawk is the best, and you can judge for yourself. We'll try it out a little bit later. I want to see if anybody has any questions before I move on.
So we've got a question in the Discord. If one has limited resources, which of these testing types should you start with?
That's a great question. I would say SCA is so easy that everybody should have that turned on all of their repos. It just takes a couple clicks of buttons in a GitHub repo to turn that on. And beyond that, because that almost doesn't count, it's so easy. Beyond that, I would say really Dast is the best way to go, just because it really finds it finds bugs in your application. It has lower false positives, and it typically has really good results.
And looks like we might have another question coming in. There was somebody who was typing, so we can wait just a sec to let them finish up. Getting those 3 dots, dot, typing.
3 dots. Well, let me know when that comes in. I'm gonna step forward.
Which services are better to use for application testing? From, is it Mapat? Not sure how that's pronounced.
Thank
So
you.
yeah, which of the 3 is best to use for application testing?
Again, I would say Dast. SCA is so simple that it's great for any kind of software. If you mean by application, if you mean an online application like a web app or an API, that is definitely Dast is the best utility for that. Now, if you have an application that is more like a desktop application or something that is not something that does not have a web API, or a GraphQL endpoint or a SOAP API, if it's more of a desktop or client-side application, SAST is actually a better tool for that. Even though you're going to get high false positives, with an application like that that isn't listening for incoming requests, Dast doesn't really apply. Dast is really focused on APIs, web applications, GraphQL endpoints, things like that.
Yeah, all of the Dast tools are assuming a browser interface or an API interface. So if you don't have either of those, they're kind of a moot point.
Cool, thanks. These are great questions. All right, the first thing that we're going to jump into is GitHub Actions itself. So GitHub Actions is, again, it's CI/CD that's built right into your repository. We all use GitHub, I'm pretty sure. So you've already got this. If you haven't heard of it, you've already got this available to you. It uses a very simple YAML configuration language to set up pipelines. And it's got a huge marketplace of what's called actions. And actions are like these plugins that reduce complicated tasks down to simple one-liner, two-liner actions that you can add into your YAML pipeline. It's event-driven, so it typically triggers workflows, which is what the pipelines are called. It triggers workflows on various types of GitHub events. So these could be like a push or a pull request, but they could also be arbitrary API calls to GitHub. So you can trigger them in various ways, and you can also have workflows trigger other workflows. So you can really set up complicated and sophisticated pipelines with it. GitHub Actions also has built-in secrets management, and that's always important when you're talking about security tools, because you never want to keep secrets in your repository directly, because that stuff will never go away. Once it gets into your history, it's hard to clean out. And that's a bad security practice. If you have a personal account, if you've got a free GitHub account, you actually have 2,000 free minutes of GitHub Actions, which is a lot. You can do a lot with that. And it's pretty generous. So here is just a little sample of what a GitHub workflow looks like. All you have to do is put a YAML file into this directory structure. in your project. So in your project, you make a .github .github/workflows, and then a YAML file in there. We have a question. The question is, are the 2,000 minutes per user or per project? I think they're per user. It's per user account. So in this workflow example, I'll just show you sort of the simple taxonomy. So in each one, you've got a name for it, and this is actually optional, but this is just so that this workflow will show up nicely in the GitHub Actions console as you watch your jobs run. This on statement says, hey, what triggers this workflow? And in this case, it's pushes and pull requests. So any pull request will trigger it, and any push to the main branch will trigger it. And this is a kind of a common setup where I want to run through all the building and testing every time I do a pull request to my repository. And then when I push it to the main branch, I want to run those tests one last time just to verify everything's okay. Within a workflow file, you can have a set of jobs. And in this workflow, we've got a single job called build. And in build, we're going to run on an Ubuntu virtual machine. So they fire up a full Ubuntu virtual machine for you. They also have Windows machines. And then we're going to run through these steps in sequence. Now you can have multiple jobs, and the jobs by default are going to run in parallel. So you've already got kind of a cool parallelized pipeline option going on. But in our examples, we're just going to do a single job with steps that happen in sequence. So the first step is usually to check out the code, and this will, by default, it will check out the Git hash of the commit that you're working on in your pull request or branch push. So it checks out the code. And then in this instance, what we're going to do is we're going to set up node. So this is just one of those actions out in the marketplace. It's actually one of the built-in actions that simplifies the process of setting up the right Node.js version. And so you would just say, hey, with, and this is sort of like the parameters, with node version 14x, let's continue with the next steps. So this one installs 14x. They also, of course, have like 10, 12, 14, 16. You can even set up a matrix where it will fan out and build this with several versions of node. Got a question. Can we select different OSs? Yes, we can. Windows, for instance. I don't know if there's different distributions of Linux, but there are options. And then finally, this workflow is going to install all the dependencies. So just do npm clean install. And that's kind of in a nutshell. That's how GitHub Actions works. So with that, let's do one ourselves. So now we're going to go to, I want to pop open this guidebook, the workshop GitHub Actions guidebook. And first thing we want to do is go over to the Vuln Node Express application. And so we want to pop open this repository. And I'll paste that in. Or sorry. Nick's going to paste this in so we can all go there.
We're going to use the thumbs up again for once you've completed that step of forking this into your own repo. And if you run into any issues, you can also use the thumbs down. And then we will see that and attempt to help you if you're running into any technical issues.
Oh, we've got a raised hand. Let's see. Joseph, you're on the line. You're muted. Joseph, do you have a question? You're on mute currently. Okay.
Oh, sorry. I was just figuring out how to do the thumbs up. That was a mistake in raising my hand.
No problem. Thanks, Jess.
Yeah, appreciate it. Thank you.
All right. Okay, so we're here in the Vul Node Express application. This is the one that we are going to fork off so that we can test with it. So just head over to this fork button in GitHub under Vul Node Express and just punch that button. And for me, I'm going to move it over to my my Conger organization, my personal organization. I recommend that you do the same. And there we go. So then when you do that, you should see that you've got a copy of Vul Node Express in your organization. And you can see that it's forked from this other repository. This is what we're going to work on. I'm gonna wait for a moment, and we'll wait for thumbs up to make sure other folks were able to fork it down. And in the meantime, I'm gonna sneak off because I think I forgot to reset something for my demo here. All right. Cool. Again, in the Discord, we are, Marat asks if we should open this on an IDE. We're actually going to do all of this in the browser. You can pull it down and open it in your IDE if you want to, but we're not actually going to even fire up this application. I can do it a little bit later if you want, and you're welcome to as well. So just to show that again, one more time, if you go into the if you go into the Kaka Vul Node Express repository, just hit the fork button up here, and you can fork a copy into your own repository. It's like we got 16. Give us a thumbs up in Discord for the Vul Node Express repository if you were able to get that forked into your own repository. Cool. Awesome. Lots of thumbs up. Super cool. Rocking. All right. What do you think, Nick? Should we step forward? Okay.
Yeah, let's do it.
Cool. Okay, so we've got our forked copy of Vul Node Express. If we were to run this, it's just a simple API. If you want to try it yourself, maybe do this a little bit later, but you can, we've got a nice README here. You can run this thing yourself and even try some vulnerabilities, try to exploit the app. But we're going to let the tools do it all for us. So the first thing that we want to do is, what we're here to do is set up our first GitHub action. So we're going to set up a new workflow, and we're just going to do it right here in the browser. So go to Add File, create new file. And we want to set up in the .github directory. And under that, the workflows directory. I'm going to set up a file called build and test.yaml. And this directory structure is very important. GitHub Actions looks by default in the .github/workflows directory, and any YAML file that it finds in there, it's going to assume that's an action workflow, and that's what we're building. So call it build and test.yaml. We're going to give it a name, just like in the example before, build and test. We're going to run this every time we do a push to the main branch. And we're also going to do it every time we do a pull request to any branch. So formatting is important here. This is YAML. And so 2 spaces for every indent. And keep in mind that if you get stuck here, you can refer back to here. This is exactly what I'm working on entering. So if you have any problems with this new file that we're creating, you can always copy and paste from there. All right, so we're going to set up a single job called build and test. We're going to run that. Oops. Test colon. We're going to give it a nice, pleasant name to show up in the Actions console called build and test. We're going to run it on an Ubuntu VM. So Ubuntu-2004 it runs on. We're going to set up a couple of steps to get started. First, we're going to check out some code using a built-in action called checkout version 2. After checking out the code, we're going to install Node.js 14. We're going to use another action called action node. Action setup node version 2. And I'm going to add a parameter to that using the with flag. We're going to use node version 14.x. Finally, we are going to add a step to install our dependencies. We're going to do that by running npm clean install. And that should be it. If I type this all in correctly, this should run an action as soon as I check it out, or as soon as I check this in. It's going to check out the code, install Node, and install the dependencies for the app. And that should tell me if this app is going to work. So I'll commit the file, create build and test.yaml. Seems like a good commit message. Hit commit new file. So we should stop here and see if folks are caught up with us. Nick posted a checkpoint here, create GitHub workflows, build and test YAML. Just give us a thumbs up if you're ready. Are the uses field methods from a library? So this uses means to use one of the GitHub actions. And I'll take a slight diversion here and show you the GitHub Actions marketplace to show you what this means. So these are like modules or plugins in Jenkins.
So Perkele noted that when you typed in the code under the uses command, you have action without an S. And in the guidebook, it's actions with an S. So I wanted to double check and see if that was a typo.
That is a typo. Great catch. When I did that, of course, it didn't work. Error unable to resolve the action checkout to. So thank you for that catch. That's right. So I'll need to update this.
Good catch, Perkele. You get extra brownie points.
Yeah, give him 2 entries in this for the swag. Oh wait, did I even? Oh, I'm in the wrong repo. Okay. Head back into GitHub workflows, edit this file, update these to actions. Commit. Head over to the actions tab now. So once you've checked it in, you can just click over to this actions tab. You should see any running workflows. And so now that I fixed my bug, my workflow is running. When you click into, so this view back here is going to show all of your runs, and this message here is my commit message. So I'll click into the build and test job, check on the steps. So it has a couple built-in steps that it's working, that it's already worked through. Now it's working on installing the dependencies, which is the final step. And then it's got a couple built-in extra steps where it wraps up anything from previous actions. So hopefully everybody else is seeing the same thing I am. You've got your action running. We can watch the progress here. It's going through a long dependencies install process. SQLite has to do some C compilation. Always takes forever. All right, and everything checks out. So we get a green check mark, a little dopamine rush. We've succeeded in our first task, which is to set up this GitHub action. Now I want to stop and see if anybody's had troubles. All right, we've got one error, that jobs is not a valid event name. Heito, can you, is it possible to paste in the error that you're seeing and where you're seeing it? Oh. Heito, I have a hunch that your formatting may not be correct, that it may think that your jobs entry is a subsection of the on flag. So make sure that jobs has no indentation at all. It's back at the root. Awesome. in this case, which one has Ubuntu 20.04? So Ubuntu 20.04, what that says when we say runs on Ubuntu 20.04, when this action runs, it actually fires up a virtual machine running Ubuntu 20.04. And that's what all of this stuff is running on. So when you're looking at the logs, the action logs, this is all essentially console output on an Ubuntu 20.04 machine. CE12 asks, so this is like Python where indentation actually affects how the code runs, and it's not just for readability. and that's right. That's how so YAML is a superset of JSON. And so this configuration file is essentially a JSON file, and it might actually work as a JSON if you format it as JSON. But yes, formatting indentation is important in YAML. All right, I'd like to move on because we've got a lot to go through. So I want to move on to our next step, if that's cool with everybody. Looks like we've got a lot of people caught up. Okay, so our next step, what we want to set up is Dependabot. And this is, again, this is software composition analysis. It's built into GitHub. This is actually enabled by default on public repos, but since we forked ours, they don't enable it by default. So we're going to enable it manually. And this is also free on private repos. And so the steps that we go through are the same steps that you would take to enable it on a private repository. Totally free and available. So again, this is going to go through and look at your dependencies. It's going to find any vulnerabilities in your dependency chain. And one of the cool things about it is it actually also automatically issues PRs for fixes when it finds vulnerabilities, if it can automatically fix them. Okay, so let's not waste another minute. Let's get started on Dependabot SCA. So if we jump back into our repository, let's head over to the settings tab. You can also do this from security. I'm going to show you the secret back route into it. So we'll go to the settings tab and go into security and analysis. And in security and analysis, there are these three features that we want to enable to make Dependabot work. First is dependency graph. So this allows GitHub to reach in and find your dependency files like package.json and packagelog.json and crawl through those and basically crawl all the way through to find the dependencies of your dependencies. So it can do a more thorough scan. So enable that. Dependabot alerts lets Dependabot tell you when it finds vulnerabilities. And then Dependabot security updates enables Dependabot to actually issue PRs when it finds problems. So I want to make sure everybody found this under the settings tab, security and analysis. Yeah, give us a thumbs up when you've got that. Sweet.
And then just if you do have any issues finding these settings or get stuck, just give us a thumbs down as always, or type a question or post a screenshot if you're running into issues, and we'll help you figure out what's going on.
The check failure should be set as well. Salocin 10, the check failure should be set as well. I'm not sure what you mean.
Can you give us a screenshot of what you're looking at? Oh yeah, we will do setting up the code scanning next. We're just pausing after the first three that we're turning on.
Oh, right. And it's okay if you enabled code scanning. Oh, right. Nice, Marat. Marat's ahead of us. If you mistakenly enabled code scanning, that's okay. We're going to come back and do that later, but it's okay if you already got it. Don't worry about it. Okay, I'm going to move forward. So hopefully everybody's got these three features enabled. And so what you should notice now is that there's already this badge on the security tab, 7. And that means that it has found 7 things. So if you click over to security, click over to the security tab, you should see over here under Dependabot alerts, there's another 7 badge here, indicating that there are 7 Dependabot alerts. And so this is cool. It's just showing us all of the problems that it found and giving them a label of how severe those issues might be. Let me click into Pug just as an example. So you can see in here, it says, hey, we should bump Pug from 204 to 301 because I found a vulnerability in 204. And down here, it shows the details of the problem, which you can read at your leisure. There's workarounds and patches. So it's recommending that, hey, just jump into your package lock.json and add, update your dependencies for Pug. Very simple fix, easy to do. And if we wait a little bit longer, I have a hunch that later on in this workshop, we will see, oh, here it is. So if you click over to pull requests, you may find that there's already a pull request from Dependabot saying, I would like to bump Pug. And what it's done is pretty cool. It issued a PR for that and it ran all the tests. And so it ran the workflow that we set up initially and it found that it worked. So we know that we're safe to merge this pull request and fix the problem. So I'm just going to back up and walk through these steps one last time. We went to settings, security and analysis. We enabled dependency graphs, Dependabot alerts, Dependabot security updates. And then immediately we had 7 security alerts under Dependabot in the security tab, Dependabot alerts. And Pug was one of them that it found that was a problem. We saw the recommendation and the vulnerability. And we saw that it automatically issued a pull request, ran through our existing GitHub Actions to make sure that it didn't introduce any problems to try and upgrade this. And now we're invited to merge the pull request. Boom, problem solved. And you'll find over time, it's probably going to issue some more PRs over time.
Do you know where it's pulling those severity scores from? Is that from like something like CVE or something like that?
Yeah, I believe it is the CVE. So we can click into one of these guys and look at the details. Yeah, CVE 2020-778. And you can actually click out to see the advisory.
Oh, that is awesome. Very slick.
Super slick. Yeah, really great tool. And Sneak has similar features to this. Sneak is another one you should check out if you're interested in this kind of tool. All right. Got to keep moving. We cut back to my slides. So we just did Dependabot. And now we're going to look at CodeQL, static analysis. So again, with SAST, static analysis or static application security testing, this one is going to crawl through your code, compile it, put it into a database, and run a bunch of queries against it looking for vulnerable code patterns. Again, it kind of has some high false positives. But over time, these tools are getting better and better. And for this particular tool, CodeQL, there's an open source library of plugins for it or queries for it. So people are constantly contributing new checks for patterns that would indicate vulnerabilities. CodeQL is free for open source and public projects, but it is not free for private projects. That's something to keep in mind. So if you have a private project and you want to use CodeQL, you have to use GitHub's security license, which I'm not sure what the cost is, but it's like, some number of dollars per month per user. And what CodeQL is going to do when we set it up is it's going to set up a workflow in GitHub Actions. So just like the one that we set up, but this one uses a different, so it'll run on every push, every pull request. And this is a new one, it runs on a schedule. So it basically runs as a cron job, and I'm not sure what this is. I think it's once a week, it's going to run through this on its own, whether or not you check in code. Okay, let's get started. So we'll go back to our repository and click into the security tab. And you can set it up here, or you can set it up back where we were under settings, security and analysis, code scanning here. They both take you to the same place. So I'm going to jump back to security tab and look for code scanning alerts down here and click this setup code scanning button. And in here, you'll see that there's actually a big catalog of static analysis tools. And I will point out that Sneak is in there and Stackhawk is in there too. But we're going to use CodeQL from GitHub. So we're going to set up this workflow. Click this button and it drops us into an editor where we're editing another workflow, just like the first one that we set up for GitHub Actions. And again, it's going to run on every push to main, every pull request to main, and on a cron schedule once a week. It's got a single, actually it's got a, let's see, it's got a single job called analyze. It's going to run on an Ubuntu machine just like ours. Blah, 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 blah. And it can run through a matrix. So if it finds multiple languages, it will set up, it'll set up a matrix entry for each language. And it'll run all of them in parallel. You don't have to edit anything in this file. I'm just showing you what's in here. Liaz says hers is set up to run every 5 minutes. I recommend that you reduce that frequency because you'll burn up your 2,000 minutes, your 2,000 free minutes. So you might want to back that down. You can even remove the cron schedule entirely and just take out this line. Okay, continuing on.
Question in the Zoom chat from Katal. He's asking, does the language coverage of JavaScript include TypeScript?
That's a great question. I am not sure. I'll bet that it does, but I'm not sure about that. That is a great question. I think you should give it a try on your TypeScript application and see what it does. I haven't tried it myself. I have a hunch it will try and compile it down to JavaScript and it will work. Okay, so then it goes through its steps. It'll check out the repo, initialize CodeQL. It'll try and build your application. And there's some notes here that say, hey, if this does not work, if you see a failure, you're going to need to enter some steps in here to build your own code. But it's pretty good at this, and it typically works. And I know that with this project, the auto builder works.
Oh, it looks like Begadin found the answer already. Support for TypeScript is bundled with the CodeQL libraries for JavaScript. So
nice.
Yeah.
Thank you. And then finally, it performs the CodeQL analysis. So if we commit this, create the CodeQL analysis workflow, we should see that it runs it immediately. And so with this create CodeQL analysis.yaml commit, that's the commit message, you can see that we've got two workflows running. They're both running in parallel. The first one that we set up called build and test, and this new one called CodeQL. We can watch that run. This one's a little bit more complicated. It ran through auto build. Now it's running the CodeQL analysis. It's running all these queries against our code. Burning, burning, burning. Hopefully this won't take long for folks. Getting a lot of thumbs up here. Give us a thumbs up in the Discord chat if you have set up CodeQL, if this is working for you. Remember to jump into the Actions tab and check the progress and see if it's running.
So an example of something that the static code analysis might be looking for is if you're doing something ill-advised, like taking user input and then passing that through to a SQL statement without escaping or otherwise, validating that input, then this tool is going to attempt to look for things like that and warn you and be like, hey, buddy, that's probably not a good idea. It's recommended that you do some sort of validation of your inputs to prevent SQL injection attacks.
All right, so folks are probably still running their CodeQL scans, but I'm going to go ahead and jump in to the security tab and see if CodeQL found anything. It's got one alert. What do you know? So this is the kind of results that you'll see from CodeQL and from other code scanning tools if you integrate them in the same way. So GitHub allows other code scanning tools to integrate into this interface. So there's a lot of them out there that will produce results in here. So you'll see this kind of list. Hey, I found one issue, database query built from user-controlled sources. This is a high severity issue. You can click in there. It also shows you the context. So if it's not finding the stuff that you thought it should find, you might want to adjust this filter to see if it's found in some other branch. Okay, so we'll click into this alert, database query built from user-controlled sources. And it gives us a little summary. And as you can see, it finds the exact file where the issue is under service search.js. And it points out the exact code. So it says, hey, I found this line where we're doing a select. We've got this like MySQL query being put together. And you just dropped a variable in there. And this is like very escapable if you don't do some confidence checking on this variable. And then it points you to the user provided variable where this came from. And you just popped open a search field in the web browser and allowed people to type anything in there, and you didn't do any error checking on it. This is just textbook MySQL or SQL injection and also reflection attack material. So this correctly identified a real bug. And then it tells you like, here's the rule in the CodeQL database set of rules and queries that found this problem. And it gives you a recommendation how you might fix it and an example of how you might fix it for your specific kind of code. Pretty cool. And some references.
We got a question from Jim. He's asking, we're checking main rather than pull request branches. Is that just to simplify the tutorial, or is that a best practice?
So in this, it's for tutorial purposes. That's why we're checking code directly in, and we're just committing it from the web browser. But yeah, in a real work situation, you would want to do PRs and have it be checking on PRs. Great question. Thank you. All right, that is CodeQL. Ooh. See if anybody has any other questions. How can we do it just for PRs? So when we set that up, it actually set up a workflow called CodeQL analysis.yaml. And you can edit this file and change the behavior. So right now it's set to run every time we push to main directly, but we could just remove this whole push section and only have it trigger on pull requests to the main branch. And for that matter, if you want, you can remove this cron job. The cron job is there because if this is a code repo that you don't work on very often, and it could go months without any action, the cron job helps sort of keep up with new vulnerabilities as they are found. All right, that is SAST with CodeQL, and looks like a lot of people have got that running. Pretty cool. So finally, the final tool in our toolbox is going to be Stackhawk. And again, this is an example of a Dast scanner. So what we're going to do with this is we're going to run this Dast scanner in the pipeline. And in order to do that, we need to bring up our application, get it running in the pipeline, and then bring up the scanner and have it scan the application as it's running. So to do that, this is an example of a Stackhawk configuration file. Don't look at it, it's not very relevant. I need a better picture here. But again, just to refresh, Dast is dynamic application security testing. Stackhawk is built on the open source OWASP Zap, which is also a great project that you should check out. But Stackhawk has worked really hard to make this tool very usable in a pipeline, really easy to instrument in a pipeline. There's a free account available for developers, and that's what we're going to look at today. So we're all going to sign up for a free account, free forever. It's got a simple YAML configuration, just a single configuration file that we need to set up to tell the scanner how to work. And without any further ado, let's go ahead and set this up. So what we're going to do, oh, thank you, Nick. Nick provided a link to app.stackhawk.com. And from there, you can set up your own new account. So when you get there, you'll be greeted with this screen. We want to sign up for a new account. You can set up a new account based on your GitHub credentials or your Google credentials or your own email address. If you do the email sign up, totally cool. It just takes a little bit longer because you need to set up your own username and password, and then it's going to verify your email. So you have to go to your email and verify and click through on that. So it just takes a little bit longer. I'm going to use Google for mine. And I'm going to use one of my many alternate identities. So when you first sign up, hopefully everybody is here. Just to keep things straight for myself, I'm going to call that Zachary Conger's workshop org. You can set your organization name to anything you want. And part of the idea of this is to make it easy to work with this tool with teams, and that's why we have an organization name. And if you were to use this later on in an organization, of course, you can invite other people into your organization so you can work as a team. But we're just independent developers today, so continue through and sign up for the free developer account. Hit continue. I mean, if you want to pay us, you're welcome to do that as well, but I recommend the free account. And then when you get to this part, hit scan my application. If you select Google firing range, that just pulls in some sample data so you can start playing with the GUI interface immediately without scanning, but we're going to scan immediately. So hit scan my application and continue. And it says, hi, welcome to Stackhawk. And it tells you what we're about to do, which is to go through a get started workflow. And this is going to set up our API key. And the API key is used for the scanner to be able to communicate with the platform. So every time the scanner runs, you're going to download a Docker scanner that you can run right next to your application for fast scans. But then when it's done with its scan, it's going to post all the data that it gathered to the Stackhawk platform, so you can come back here and analyze the data. And we'll look at that. So we'll get started. First thing it asks, first thing it does for us is says, hey, here's your API key. This is so the scanner can reach the platform. And then it also recommends that, based on whether you've got Windows or Bash on a Macintosh or on a Linux box, you can copy these commands and run them in your terminal application so that you can save your key to your workstation in a standardized place. And you can do this if you like. That might come in handy for the future if you want to continue playing with this after the workshop. But right now, I want you to copy this key, and we're going to set it up as a secret in GitHub Actions. So copy the API key, and then come back to your Vuln Node Express application. Go to Settings, and under Settings, on the left side, you should find a Secrets panel. So in here, this is where we stash secrets that can be used in GitHub Actions workflows. We're going to stash this secret, call it hawk_API_key, and paste the value in. And then add that secret. So this makes it available in an encrypted format so nobody can get to it. It's not stashed in the repository. It's often a separate secret store, so it's secure. But it's easy to pull into workflows so we can use it later when we go to scan our application and then be able to securely authenticate to the Stackhawk platform. So we're adding that secret. And then let's go back to Stackhawk. Okay, so hopefully everybody's got their API key set up. Give us a thumbs up if you're with us. And then we'll take the next step, which is to set up our application. So in Stackhawk, in the platform, you have a number of apps, and you can give them any name that you want. I'm going to call mine, what is it called? Vuln Node Express. I usually just name them after the repo name. Anyway, Vuln Node Express is the name of the application, but in the background, it's going to set up this big long UUID string, which will become important later. So Vuln Node Express, hit next. Then it wants you to select an environment, and let's choose development. And the idea here is that you may want to scan this application, Vuln Node Express, in many different environments, maybe development, maybe locally, maybe pre-prod, maybe even production, although we don't recommend that. Pre-prod is always better. Catch the errors before they make it to production. Then we want to name the host. It's going to be, in our case, HTTP localhost port 3000. And the formatting here is kind of important. It's HTTP, not HTTPS. Localhost port 3000. Don't do a trailing slash here. Our configuration file is a little bit picky about that. So localhost port 3000. And then it's going to ask us to download the stackhawk.yaml. And I think I'm going to have to widen this out to my whole desktop here. Are you seeing my full desktop now?
Yes.
Okay. Are you seeing, let's see. So when you come here, you should hit the download stackhawk.yaml button so that you download the initial configuration file. I'm going to adjust this real quick. Okay. So when you download that, in my case, should be over here, Stackhawk 22 YAML. Pull it into my text editor. And really what we want from that stackhawk.yaml is just these first couple of lines. And what we're looking at here is the Stackhawk configuration file. And we've got a section for the app. What's the app we're going to be scanning? This one represented by application ID, blah, 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 which is really the Vuln Node Express application. The environment we're going to scan in is called development. And you can have as many environments as you want, and you can call them whatever you want. You can rename this and it will just lazily create new environments in the back end to collect the data. And then finally, we're going to be scanning host, localhost 3000. So that's where we're going to run the app when we run it in the pipeline. Okay, so I'm going to take this, copy it, and let's just make a new file in our repository. So head back to your Vuln Node Express repository under code, and we're going to create a Stackhawk file right here. So I want you to add a file, create new file, call it stackhawk.yaml, and just paste the first couple of lines from that configuration file that you just downloaded. We should checkpoint here and make sure people are still with us. So again, at the base of your Vuln Node Express repository, create a single file, stackhawk.yaml, and just add the contents from the stackhawk.yaml file that you downloaded. And we can commit that file. Easy, just like that. Okay, and going back to the Stackhawk app, we can finish this process out. I'm just going to walk through this getting started flow one last time. Bear with me, just to make sure everybody sees what we just did. We're basically setting up a new app in the Stackhawk platform. First step is it gives you an API key that you can use for scanning. Then we set up an application, gave it a name Vuln Node Express, set up an environment develop, and said what host we're going to scan. And then finally at the end, it offers to give us a stackhawk.yaml file, which is our initial configuration. And this is the application ID for Vulnode Express. And that's baked into the Stackhawk YAML that you just downloaded. There's also these commands down here. If you want to, you can run a scan from your own machine, but try this later. Download the app and run it locally, and then run the scan from your local machine. Okay, and we're finished. And we're back to the platform. I'll show you the platform a little bit later, but for now I'm going to head into this scans section. And as we run scans, scan results will populate in here.
And just to note, your application ID will be different for each of you, just like your API key. That's just a way for Stackhawk to keep track of different applications that you may be scanning.
Okay. Okay, got a chat. Okay, I'm going to pop back to, so you can see my screen better. I'm going to pop back to the browser. Okay, so we've added the Stackhawk YAML. Now we need to update our workflow so that it, so pop into your build and test workflow. It's under .github/workflows/build and test.yaml. And let's edit this file using the little pencil over here. At the end of this, we want to run a couple of steps. So we've already done the npm clean install. Now we'd like to run the application. And this is a simple shell script step. We're just going to say no hup. I need the cheat sheet. This is all back in the cheat sheet, by the way, in the guidebook. Okay, so we're going to say no hup npm run start, which starts the application and makes it listen on port 3000. And we're going to add this ampersand so that it forks off into the background and we can continue on to the next step. So that ampersand is important. The no hup also detaches it from the TTY. So all of that is to say, this will run your application, make it listen, and also keep it in the background. So we can move on to the next step. And the next step is to run Hotscan. And that is going to use an action that we created for GitHub Actions that wraps up the complexity. So normally you run Stackhawk as a Docker container, but we've done this integration with GitHub Actions, so it's a little bit easier. But in the background, it's going to do the same thing. It's going to run Hotscan as a Docker container. And I can show you that. So it uses Stackhawk Hotscan action at version 1.3.1, our very latest. We need to give it one parameter, and that is the API key. So API capital KEY. And the API key is going to be that key that we stash in secrets. So that's the format. So this will pull it out of the secrets stash and populate it and feed it into Hotscan so that when it runs, it can use the API key to connect back to the platform and send results in. I'm going to check mine in. Give us a thumbs up if you've got yours checked in. And again, this is the section that we added right here. We're just taking our existing workflow and we're adding these two steps. Run the app, no hup npm run start ampersand, and run Hotscan using the Hotscan action version 1.3.1 and feeding in the API key from the secret store. This is awesome. Got a lot of people are with us. So I'm going to go ahead and head into the Actions tab and see if this is working. Okay, cool. Our CodeQL job is running, but what we're really interested in is the build and test job. So click into your build and test job or workflow and click into the build and test job. And you can see mine's still working on installing dependencies, but when it's done with that, it's going to run the app, which should be pretty quick, and then run Hotscan. And while we're waiting for this to start populating, while we're waiting for these things to run, because it'll take a while to install dependencies, I'm going to pop back over to the Stackhawk UI and just give you a quick tour while we wait. So we don't have any scan results to look for yet, but when that Hotscan kicks off, we should be getting some results. Over here in the Applications tab, this is a view of all of the applications that you might have in the system. So if you were a big shop and you had a bunch of apps, you would have an entry in here for each app. So we've got this Vuln Node Express, and the app ID is here, just handy so that you can copy it and throw it into a config file. There's this little button here that allows you to adjust the name of the app, adjust various features of the app. And if you had a pro account, there's also feature flags in here where you can say, hey, this is a JavaScript app, and it uses a SQLite database, and just sort of name some of the technologies that you use. And that helps optimize the scanners to make it run a little bit faster. Back to the Applications tab. For each environment in an application, it will show you a little card for each environment. And we'll come back to this. And this is neat because it just shows you sort of, here's the state. Here's the state of your application. Oh, here's the state of your application. And there'll be a little bar graph here that shows like all of your latest runs and gives you a little summary of the high, mediums, and lows that the scanner found. We'll come back to this. Under integrations, you can see we've got a bunch of CI/CD integrations. You can run in any CI/CD, but these are ones where we've done a deeper integration or we've written out a guidebook to help you get started with those quickly. We also integrate with Slack, Datadog, and Microsoft Teams for notifications. So using Slack or Microsoft Teams, you can get notified when there's new scans or get notified when there's new high severity alerts, for instance. If you integrate with Datadog, you can send all of the scan events into Datadog for data collection. We also integrate with Jira so that as you have vulnerabilities found, you can actually send those vulnerabilities into Jira so you can start tracking them, assign them to developers, and then as they fix them, they get cleared out of the scan results. And then finally, if there's any other integration that you would like to do yourself and we don't have an officially supported one, we do support generic webhooks. So you can send all the scan result data and events to a generic webhook. Finally, you can invite users to your organization if you like. And you can go into your settings and change your organization name, create new API keys, look at your account details, and so forth. All right, I'm going to pop back up to scans and see if we already have scan results. Widen this out so we can see the whole thing. So before I show you the scan results, let me jump back to the actions workflow. So under run the application, that new step that we did, very simple step, just started up the applications. And then we ran Hotscan. And when we run Hotscan, we had a very simple Hotscan action statement. It's just a couple lines. What that blows out to and what you would do on your workstation if you want to run Hotscan locally is this Docker command. And just to step through it, it's running Docker run Hotscan, basically. We've got a couple other flags here to mount the volume where your repo is so that it can find your stackhawk.yaml configuration file. We sent in an environment variable for your API key, so that it's got the API key, so it can connect to the platform. And that's really just about it. Then it pulls down the container and starts Hotscan. And if you were to run this locally, you would see this sort of summary as it gets started saying, hey, I'm the latest version of Hotscan. I'm running against this app ID in this environment. Got a scan ID, this big number for tracking later if you need it. I found this configuration file. I'm scanning this host. And this is not a GraphQL application. And it'll give you some other summary information if you've configured advanced features. Then it runs through the scan. It tells you what it crawled. And it gives you some summary information about findings. Then finally, it gives you a link back to the platform. And in the platform, we've got scan results. So I can click into this latest scan and see the scan details. So it gives us a summary. Hey, I found 3 high severity alerts, 11 medium, 18 low. I should stop actually and make sure everybody's caught up. Are there any questions or problems people are experiencing?
Most everybody seems to be scanning successfully. C1 Sue did run into an issue where his build and test failed on the Hotscan. It said unable to find image, Stackhawk Hotscan latest locally. Posted a screenshot in the Discord.
Take a look at this. Fascinating. Docker run, blah, blah, blah. Stackhawk, Hotscan latest. Oh, this is okay. I think it's saying it didn't find it locally, so it's going to go pull it down. So if you look at the rest of that, oh, but it
pull down then.
But then it failed. What does the rest of it say?
Yeah, could you get us a screenshot of the next couple lines? Yeah, that's a good call from Murat. If you don't have the API key set up correctly, that can cause an error.
Yep. If you look at the rest of the output in the run Hotscan step, at the very end, it should show you what the error was or why it failed. And let me show you what that would look like, as a matter of fact. I go in here. So what I'm hoping you will see is that it says unable to find the image locally. So we're pulling the latest. It pulls, pulls, pulls. And you should get to this part here, and it should say, hey, I'm running Hotscan version this, but I found an error, fail. And here's the reason for the failure, somewhere right about here.
So it's also not finding your stackhawk.yaml file. So that'll be the next thing to check after the API.
Yep.
Is to make sure that you're seeing a stackhawk.yaml file in the root. Yep, so it looks like you have the API key in there. So as long as that was pasted correctly and you didn't accidentally miss a character or something, then we should be good.
So take a look at the root of your repository and make sure you've got a stackhawk.yaml file here. I love all the community support in here, you guys. This is great. Yeah, it looks like there's a typo in the file name. Shackhawk instead of Stackhawk.
That's it. Yeah, if you just edit that file name to Stackhawk, then we should be good.
What a great crowd. So helpful. Thank you, everybody.
Indeed. As a community manager, it warms my heart.
Okay. Now I'm going to head back to the Stackhawk console, and hopefully other people are seeing this too. We get a nice list of the findings, got a cross-site scripting problem, SQL injection that the Dast scanner found, anti-CSRF token scanner, blah, 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 blah. Lots of vulnerabilities, including 3 high alerts. And there's this summary information up here. There's also these tabs up here that are kind of fun to watch too, can be useful for troubleshooting. Under the paths tab is all of the paths that the scanner found when it did its initial spidering. So first pass the scanner takes is to just spider the site like Google does, finds the home page, any links in there it follows, and then it follows any links in those 2 pages and so forth. And then the plugin summary for each of those routes that it finds, it runs these plugins against them. And the plugins contain suites, sets of probes, and attempted attacks that it's going to take against your application. And one thing to note about these probes is that they can be destructive. So it's an aggressive scanner. And this is one reason we don't recommend running in production, is that it will try and hack your site, and it will try and change data in your database and stuff like that. So do be careful if you want to run it in production. We do have customers who do successfully, but you just need to be aware of the fact that it's going to try and do a little bit of damage as it runs its scans. Back to the findings, if you click into an individual finding, like let's take SQL injection as an example, they'll give you a bunch of detail about what it found. Zoom in a little bit here. So first off, it says, hey, found a SQL injection. It's in this category. It talks about remediation and what it is and what the risks are. And it links out to some cheat sheets for different platforms that you might be using. Over on the right pane, we've got request details. So it shows us as much information as possible about the probe that it launched against your application. So it made a request to your application, it posted to it. These are the headers that it submitted. And then this is the body that it tried to send in. And it tried to send in a little bit of, actually, I'm not sure what this is trying to accomplish. But then the response that it got was, what did we get? Search results for ZAP N1 equals 1. So it determined that it could run a little calculation, I think is what it's getting at.
That and 1 equals 1 is what indicates that, hey, it's letting in additions to the SQL statement.
Yep. So now you've got all the details. What was the request? What's the response? And you can also hit this validate button to get a curl command to do the same request, so you can verify that you've got the same response. You can take actions on this. So from here, for each path, you can take the actions and you can accept the risk, or do a false, mark it as a false positive if you don't believe this is a real issue. Or you can assign it to other users. And if I had an integration with Jira, this would actually generate a Jira ticket with a ton of information about what the problem was, which app it was working against, which environment it was, has a link back to this scan result so that any developer who comes and picks up this ticket can come back to this scan result and validate the issue for themselves. When you triage it in this way, let's triage this one. I don't have the integration, so I'm just gonna say, Zach has this, hit done. And then let me go back to the summary page. And you can see for SQL injection, we no longer have a new alert, it is assigned. And so now when we run this scan in the future, this won't count against us as a new high severity alert because it knows that we've already triaged it, we've handled it in some way, got somebody working on it, or we've accepted the risk. And where this is useful is you can configure Hotscan to fail if it hits a certain threshold of severity. So in this case, a lot of times customers will set it up to fail if it finds high severity issues. And that will break the pipeline so that say you did a PR and it runs Hotscan and it fails because we have some high alerts. That blocks developers from pushing new security vulnerabilities into the main branch. But if these issues have been triaged, then they can resume issuing PRs, because you may decide, okay, this is bad, but we're going to work on it. It's okay for it to be in production for a little while. I think maybe for high alerts, you'd want to fix that bug immediately, but just to show you the feature set. Let's look at another one, cross-site scripting reflected. In this one, same sort of thing. We've got some remediation information for this, some links out to resources that you can look at to understand what this issue is. Again, we've got the request. Here's a little evidence tab, the headers, and here's the, oh no. And then here's the critical piece of evidence that it found that indicates that it's a problem. So that's kind of that. And then if I run this scan again, head back here, and I'm going to check in some minor thing. Let's just do a minor edit to this file to kick off another code build. Delete a line. Commit changes. Now it'll run another scan, and eventually when we come back here, we'll see more scans show up in the scan list. I can also now, I can go back to applications and show you this graph is starting to fill in. So as you remediate alerts, or you remediate vulnerabilities, you should see a bar graph that's, the old items are high alerts, and then it reduces and reduces and reduces to hopefully 0 once you've fixed all your bugs. All right, we're getting some questions. I'm looking at the Zoom chat, and we've got, are actions trackable? In the sense, if assignments are audit logged? Yes. Yes, we do have audit logging. So, so it is possible, this is a developer-oriented tool, so we want developers to be in this process every day. And so we want them going in and triaging these issues and marking them. Really, we want them assigning them to themselves. But if they were going in here and just marking them as false positives without really knowing what they were doing, or maybe just trying to sweep them under the rug, yes, there is an audit log that's available in the enterprise edition of this that you can get to. Security professionals can go and look at this card and start to analyze, okay, the latest state of my development environment vuln node expresses that I've got these issues, but it looks like one is assigned and maybe a couple others are risk accepted. And this is a clue that a security professional can go in and look, hey, I want to go and audit these things. And so they can go into the latest scan and see what items have been triaged from the set of alerts. But yes, there's an audit log that you can get access to in the enterprise plan.
Yeah, that is an excellent question and a key feature, because your auditors are going to want to see that kind of stuff when they come in to look at your security. Like if you're going for your SOC, audit process for your company, they're going to come in and look at those types of audit logs.
Another great question. Can you get a trend? Like 2 weeks ago, we had this status. Now it's better or worse. So sort of a hand-waving answer perhaps, but you can look at the trend line from this, and it doesn't show you time, it shows you per scan. So each one of these bars is going to be another scan result. Let's see if we've got another, yeah, we've got another scan result. So we should see an example of that. Now we've got 2 bars, and that'll just fill in bar after bar, scan after scan. So it's not really time-based, it's set of scans. However, you can integrate with Datadog, for instance, and be sending your scan results into Datadog, and then you can slice the data any way you like. We're always interested in getting feedback like this from users, like, oh, if you had a trend view like that that was time-based, how useful would that be? How would you use it? So we're really eager to hear questions like this. Gives us ideas about features we can add to the product. Great question. Another question is, can you manually run the scan? If you run the application locally, you can scan locally. And from the GitHub Actions run that we did, you can see exactly what the command would look like. So to run Hotscan locally, you would run a command like this. You'd say docker run -tty so that you get console output, because it likes to spit output out at you. So you can see what it's doing. This --rm just removes the container when it's done running. Volume mounts the volume, mounts your current working directory, which is where we expect to find your Stackhawk.yaml configuration file. It mounts it to a /hawk directory within the container. And that's where Hotscan expects to find your configuration. You need to send in an environment variable with your API key so that it can connect back to the platform. In this case, we turn on network host, which gives the container access to your local network stack. And that just makes Stackhawk run a little bit faster and tends to eliminate any network problems that it might run into. There's more complicated networking scenarios. We've got it all covered in our documentation. But this is usually a good flag to turn on for Docker. It runs the Hotscan container and it found this configuration file. So that's how you'd run it locally. You just run this at the command line. Oh, that's a great point, Doran. Can you use it on different kinds of code? That's one great thing about Dast scanning, actually, in general, is that it doesn't care what the application is listening, what it was written in. In fact, it doesn't even know what it was written in. You can set technology flags in our application. If you've got a pro account, there's tech flags, which says, and the tech flags feature allows you to say, hey, this application is written in C# and stuff like that. And then it helps the scanner tune itself to that specific application, knowing that there's certain vulnerabilities that only apply to C#, but not Java, for instance. But yeah, in general, Dast scanning is doesn't care about what language you use. So if people are sensitive to time, I want to give you your time back. We're done with the main show, but if anybody wants to stick around and ask more questions, these are great questions we're getting, and I'd love to answer more about it. If you look in the GitHub Actions guidebook, this workshop GitHub Actions guidebook that everybody's been following through, at the very end, there's a section about where you can go to read more about stuff. So I've got some links here to get you to documentation for GitHub Actions, CodeQL, and Dependabot. Link out to the marketplace so you can see other GitHub Actions that other folks have created. And then I've got a couple of resources here for Stackhawk. So if you want to continue looking into Stackhawk, we've got a great set of documentation. One thing you'll want to do if you continue with Stackhawk and you're scanning your own applications, you usually want to authenticate the scanner to your app. So this is a whole section we haven't talked about, but Hotscan is really good at authenticating so it can get deeper into your application, because most of the interesting stuff is behind a username and password. We've got documentation on continuous integration. So if you're using Argo CD or Jenkins or Circle CI or whatnot, we've got guides for all of those. And we've got a Stackhawk blog where we've got lots of tips, tricks, and walkthroughs to help you test your applications. We've also got a lot of like strategy pieces in there. It's not all about Stackhawk in particular. It's really been a pleasure. Thanks everybody for participating and for helping each other out. This has really been a good workshop. This, I think, has been my favorite so far. And thanks so much, Nick, for helping out in the chat.
Yeah, this was a lot of fun, and I'm glad that everybody got through it with minimal difficulty and very few technical hiccups that we're able to iron out pretty easily. And yeah, if you guys do have follow-up questions later on, you can always reach out to us by email or on Slack or other places, or we'll continue to be in the Discord. We also have a Stackhawk Discord that you can join if you want to come in and ask questions that way. And then we will at some point be launching an online community forum for people to come in and ask questions or provide feedback or just chit chat, and to do further workshops like this. So we're looking forward to having a lot more. Murat is already asking for homework, so yeah. yeah, dig into that. Dig into our blog. Your homework is to take this to your favorite application and apply it to your favorite application, and see what you can find with your own applications, and see if you can fix some of those problems. Yeah, I would say if you're looking for a good next step, most web apps have some form of authentication, and there's a blog series on our blog that Aaron put together that covers how to authenticate into your web application. So those are good to run through. And again, it's got a sample app that you can go in and set up the authentication and get that running so that you can see it scanning, URLs that you have to be logged in to get to, and things like that.
Ooh, Berta, great. Let's see. Somebody asked, how does the spidering engine work? And it reminds me that I forgot to point out that in addition to this basic web spider that works like a Google spider, we've got features so that you can scan your OpenAPI app. So we can look at your OpenAPI spec and get a bunch of information about exactly what routes are available in your API. Or if you've got a WSDL spec for a SOAP app, or if you've got a GraphQL introspection endpoint, we can hit all of those and get a lot deeper information about where the good stuff is in your application that you can scan. All right.
And then the spidering engine for URLs obviously relies on those being linked to. So if you've got orphan URLs, we're not going to find them, but anything that is off the root page is linked to or linked to or linked to, it's going to go through all those URLs and attempt all of the different ways to break in that it knows how. All right, any last questions before we call it a day? For the swag, Liaz, you just have to complete a scan successfully, which you've already done as part of this, and you'll be entered. And then we will be tracking you down and sending swag to the winners. I believe we're doing that next Monday. So we'll look for communication from us through Discord. And if you don't hear from us, you can always ping me. I'm always on Discord, so you can reach out to me just by direct messaging me on there.
Good stuff. Thanks, everybody.
All right, thanks. Thanks for attending. It was fun working together with everyone.
Yep, had a great time. Great crowd. I think you guys like the show. We love the crowd. Like, this really has been the best crowds. It's hard on these online communities sometimes, on the online workshops, to get feedback from people, and you guys were helping each other out. This is awesome. Great.
Yeah, it was definitely a great audience. So thank you, everyone.
Catch you guys later. We'll see you at the next one. Bye now.